I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Today we're going to talk about the transformations of sine and cosine. There are 4 of them. And I thought about putting it in one really long video, but I thought I'd lose a couple of my students along the way. So I decided to do 4 short videos. We'll do one on amplitude. We'll do one on period. We'll do one on phase shift, which is a sideways shift of sine and cosine. And we will do one on vertical shift, that is raising the graph up and down the y-axis. This video will talk about all 4 of those, but at the end, we will only graph amplitude. It says I can graph sine, cosine, and their transformations on the TI-83 calculator. I can visualize changes in amplitude of sine and cosine that can form new functions. I've given you 3 other videos besides my own that will go there. Then I've given you this bottom one. Math is fun. Algebra has all the amplitude, frequency, and phase shift that we can have. It has all the functions explained in one long lesson. Let's start with the old school. In the old school, there are, on the unit circle, 16 places where we can get an X and a Y coordinate. The cosine, of course, is X. The sine is Y. We have all these. And so when I was in high school, thousands of years ago, before we had graphing calculators, before we had any calculators, we actually wrote all 16 of these down in a graph. And the graph looks something like this. I've done it now with just, hey, what happens at 0, 90, 180, 270? There's 4 of them. The real graph I had in high school would add all 12 of these. Then we would plot the points on graph paper and draw our graphs. When we're graphing on this calculator, we're going to start simple graphing with mode in radians, and we're going to zoom trig. Now in radians, instead of having a -10 and a +10 over here on our calculator edges, I'm looking for 6.2 and -6.2. Why am I looking for 6.2? Yes, because it's 2 times pi. 3.14 times 2 is going to be about 6.2. And negative 2 pi would be about negative 6.2. So the graph I'm looking at is going to be happening between 6.2 and -6.2. And the graph for trig goes up to about 10. You could change the TI-83 and 84 to do exactly what you wanted to do. You could change the graph to change every 15 degrees, every 30 degrees. You could change it every 45 degrees. We're just going to rely on the basic zoom. You hit zoom, hit 7, you get trig, and we'll see what that does for our graphic. Now, since you have the graphing calculator, I'm not going to make you graph 16 points. That would just, I don't want to punish the class, so we're not going to do that. We're going to put in y equals sine x, y equals cosine x, and then we're going to talk about amplitude. Now, before I get to amplitude, here is a chart that has all 4 of them in it. A is amplitude we're going to talk about today. It's in front of the sun. And I will show you on a graph in a minute what it does. In my illustration here, 3 is amplitude. K is period. Period is normally, when K is 1, the period is 2 pi. You're going to repeat our humps every 2 pi. We'll show you that when we get to the graphic. Now, if you change K, you can compress the humps or you can widen the humps. Then we have C. C is the vertical shift. If you take and you have your sine graph, and we'll show you what that looks like in a minute on the calculator. If you have a sine graph and you want to move it sideways a little, then you would hit, C could be plus or minus, and we would actually move the graph up and down the x-axis. Then we have D. D comes after, it's outside the parentheses. It's at the very end. And D would move our graph up or down. What's our graph look like? Let's go find out. Now I'm back on my graphing calculator for the big screen, but you're going to be using the TI 83 and 84 calculators we have here in the room. They should be set up already on, hit zoom, hit 7 for trig, and your calculator should be set up in radians. And once again, 2 pi radians is 6.2, and negative 6.2 would also be negative 2 pi radians. So the first thing I need you to put in your calculator is y equals, hit the y equals button, but I actually have to spell it out, sine of x. Now that's the sine. So let's go down one more and I'll show you the cosine. It's going to look exactly like it, except for what? Wait, when sine is 0, cosine is 1, yes. And when cosine is -1, sine is, 0, that's right. So this is, the blue one is now cosine and the red one is sine. Hey, when this one's at 1, this one's at 0. When this one's at 1, this one's at 0. When this one's at 1, this one's at 0. When this one's at -1, when cosine is -1, sine is 0. Now, when I'm dealing with amplitude, I don't need the cosine because you can see the cosine is the same as the sine. And in my third video, I will move sine sideways 90 degrees, and you'll find out when I do that, it's exactly cosine. But right now, I just want to talk about amplitude. So I'm going to keep that y equals sine x. I got to be able to spell sine, sine x. And we said amplitude goes in front of the sine. So let's just pick a number between 1 and 5. Okay, he picked 4. Y equals 4 sine x. What did I do? I made everywhere there's a -1 is now -4. Everywhere there's a 1 is a 4. If we went back to the graphing chart, the T graph, all those 16 things we can get from the unit circle, we would just multiply them all by 4. When this was -1, it's now -4. But have I changed the actual points where it crosses? Now, we're not going to talk about period today, but a period is from -2 pi to 0, and it's from 0 to 2 pi. Basically, a period is 2 humps. 1 down hump, 1 up hump. Then we start again. It goes on forever, so I'm only going to do that once. But now take a look at the green. 1 down hump, 1 up hump. It still ends at 0. We didn't change how wide the waves are. We increased the size of the waves. Now that brings on 2 obvious questions. Can we shrink the size of the wave? Okay, Rufus says that if we shrink the size of the wave, all we got to do is put a minus in front of the 4. Let's try that. Okay, Rufus, I'm not sure what we got here, but hey, when sine was 1, it's now -4. When sine was -1, it's now +4. And I asked if we could shrink the wave, and all we did was change it vertically. We went from 1 to -4. So that won't do it. If we're going to shrink the wave, what can we put here? Okay, what happens if you have a whole number and you want to shrink it? We call that division. So yes, now Rufus wants to use a fraction. So let's just put in, I don't know, 1/2. 1/2. Now we shrunk the wave. It was 1, now it only goes up to 1/2. The period that we'll talk about in that next video goes from -2 pi, 1 up hump, 1 down hump, comes to 0. It's still 2 pi. We didn't change the period. It still hits the X graph at the proper places. All we did was make the graph smaller. Can I make it even smaller? Yeah. Get rid of that 1/2 and let's make it 1/8. You can just barely see the graph now. It's up here. So now, what did we learn about amplitude? We learned that amplitude goes out front. We learned that the amplitude goes out in front of the sun. And we found out that if it's a big number, it makes the waves taller. It makes the waves lower. So amplitude has to be absolute value because sometimes it's going to plus and then sometimes that hump goes down to minus. So amplitude is absolute value and it made the waves either taller or more in depth. It went higher and lower on the y-axis. So amplitude goes out in front, and we found out that if you take amplitude and make it negative, we found out what happens. It reverses the sign, but it still goes taller and shorter. And we found out that if you make it a fraction, you can make the waves skinnier. They are still the same width. Skinny may not be the right term, shorter. That if you take amplitude out front and make it a fraction, the waves are shorter. They're no skinnier. We'll talk about skinny when we get to period. So that's what we found out today about amplitude. Watch the other videos and it'll make more sense to you after a while. This is our second topic about the transformations that you can make with sine and cosine. Today we're going to talk about periods. We've already talked about amplitude, and I wasn't sure if this was going to be 4 videos or 1 video. So I compromised. I'm going to have 4 separate videos. I'm going to have 1 long video. We'll put them both on the channel. We'll see which one y'all prefer. But today, in this section, we're going to talk about period. Now, from the unit circle, we know that we have 16 points we can graph. This is X, this is Y, this is cosine, this is sine. So we have those 16 points. Once again, when I was in high school back thousands of years ago, we graphed all 16 points on graph paper. Then we made all 16 points multiplied by 3 to get amplitude. Then we actually changed the period. When I change the period, I'm going to change the wave humps. I'm going to either compress the wave or expand the wave. Many of you, when you were a child, had something called a slinky. You could pull it and stretch that big old spring pretty far and then let go and whack your little brother in the face with it. Or you could compress it and push it so far and then eventually the slinky would come back out. Same thing we're going to do with the sine and the cosine waves. Now, I'm not going to make you graph all those points, so let's go to the graphing calculator. Graphing trig functions on the TI-83, we're going to start with mode of radians. How do you know your calculator's in radians? You can either get on the screen and hit the mode button and find out, or you can do what I make the geometry and the Algebra 1 students do when they pick up your $125 calculator. I tell them to hit the sine of 30. If it comes up 0.5, then you're in degrees, not in radians. The other thing we're going to do is you want to zoom. We're going to use a standard trig zoom. So go to zoom and hit 7 for trig. That's going to give us a screen from negative 6.2, which is pi, negative 2 pi, and 6.2 positive, which is positive 2 pi. That's going to be your basic screen. We could make it where it covered 8 pi or 12 pi. But I think the standard zoom trig screen is going to be the best for showing you what period will do. Now, we have sine and cosine, then we have their basic transformations. We talked about altitude. The what? It's not what? What's the difference between altitude and amplitude? All right, we'll call it amplitude because altitude might not be the same thing. Amplitude had absolute value. That is, it not only went tall, it also went down under the axis and came back up. So if we change the A, we change the amplitude. Then we change the K, we're going to change the period. C talks about shifting sideways, taking our graph and transforming it, sliding it sideways. And D is going to talk about taking our graph and raising or lowering it on the axis. So today we're only going to talk about period, which is the K. The normal period is 2 pi divided by K. When K is 1, the normal period is 2 pi. What do I mean by a period? It's 1 up hump and 1 down hump. Complete. You start here, you go up, you go past the x-axis, you go down, you come back to the x-axis. That's a cycle. That's a period. It is 1 up hump, 1 down hump. Now, that's what a period is. It's one cycle, 1 up hump, 1 down hump. How do we get the period? It's going to be right there in front of x. When we change x, it's normally 1x. When we change that, we'll get a different period. So let's go to the graphing calculator. Once again, I'm on my graphing calculator because it works for the really big screen up here. But you're going to be on the TI-83 and 84 we have within our classroom. So you've already got your calculator. It's in zoom, trig, and it's in radians. Those are the 2 settings you need. We're going to see the hump. And we all know from the other day that sine of x, y equal button sine x should look like that. How do we know it's sine? What's the sine of 0? 0. What's the sine of 90 degrees? 1. If we were plotting sine and it didn't come up 0, it either might be cosine that we're actually looking at, or it might have a shift, and we'll talk about that in the next video. We said all we got to do is put a number in front of x. So what happens if we want to put a positive number in front of x? And I'm going to choose 4. So let's do that. Y equal sine 4x. What have I done? I've compressed the wave, right? The wave's compressed. We can talk later about what this looks like on an energy curve. Is this more energy or less energy? We also might apply it to a scientific concept called frequency. But let's just look at, let's look at our 2 pi's. 1 hump, 2 humps. Regular sine has a period of 2 pi. Then we have 2 pi positive, 1 hump, 1 negative hump. We set out at 6.2, which is 2 pi. Now, that's the regular sine curve. Now let's look at 1 hump up and 1 hump down in sine. 1 up, 1 down, we're back. That's 90 degrees. Because sine of 1 was the first time sine was 1 was at 90 degrees. That's 90 degrees. What have I done? I've got my period. How do I find my period? You take 360 divided by 4. And 360 divided by 4, sure enough, it comes out 90 degrees. So now instead of taking 2 pi to complete my sea serpent humps, I'm doing it quicker. I'm getting my humps done in 90 degrees. One up, one down, we're at 90 degrees. And if you hold it right there on the cursor right there on the graphing calculator, it's telling me it's pi divided by 2, 0, which is 90 degrees. Now, we found out what happens with 4. What would happen with 10? Well, let's find out. Just get rid of this 4, and let's put a 10 out there. And now, I told you how to find the period. You take 360 divided by the number in front of x. 360 divided by 10 is 36. One up hump, one down hump takes us 36 degrees. One up hump, one down hump takes us 36 degrees. So the natural concept would be, what happens if we put a negative number in here? And what happens if we put a fraction in here? Which one do you want to do first? He really likes negative numbers. We'll do that one first. Okay, Rufus. Negative 4. We had 4 before. Let's see what negative 4 looks like. What have we done? There's our 2 pi. There's our 2 pi on sine. One down hump, one up hump. Still ends at 90, except for a minute ago, I did an up hump and a down hump. Now we're doing a down hump and an up hump. So the minus sign only changed whether we went up first or whether we went down first when we started our period from 0. When I started from 0 a while ago, I went up and then down. Now the new graph has us going down and up. So the minus sign didn't change it much. Now, what happens if I put in 1/3? What have I done to the blue graph? The red one was sine. The blue graph. Now I'm taking and I'm stretching out the wave. What's it take now? It goes from minus 3 pi to 0, one up hump. We get 3 pi to minus 3 pi. We get 6 pi. That is, our period is 360 divided by 1/3. You invert and multiply. So our new period is 360 times 3. 360 times 3. Yes, get it on your calculator. I got 1020, but let's check my math. 1020 is not right? Well, that's why I'm always telling you to check my math. Sometimes I want it checked because I know I gave you a false answer. And sometimes, like that time, I just wasn't thinking well. 360 times 3 is 1080. So our new period is 1080. 1080 degrees. You can put that in and change it to radians. And what you'll find out is it goes from one hump down, goes from minus 3 pi to 0, and then one up hump goes out to 3 pi. So when you take 1080 and convert it, you're going to find out that that's 6 pi radians. Could we make a smaller fraction or a bigger fraction? 1/2? Now we're going to do 720. Look at my humps. Minus 2 pi to 0, out to 2 pi. So that's 4 pi, which is 360 times 2. You take the number in front of x, 1/2, and you divide it into 360. So you invert and multiply and you get 720. Okay, I put a negative number out there. I put a 1/2 out there. I put a 1/3 out there. What happens if I put a 1 out there? Oh, that's right. Rufus is telling me we've already done it. There's an imaginary 1 in front of there. So I'm not going to plot 1. It would just look like the same graph. So that's what you need to know about period. How do you find a period? You divide what's in front of X by or into 360 degrees. What's in front of X into 360 degrees would give you your new period. And I'm not going to make you plot all those points. We're going to do it on the graphing calculator. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.